Alright, last section in this unit, we're going to look at the composition of trig and inverse trig functions. So recall we did composition of functions, again, in the previous unit, and recall the definition of inverse function if f and g are two functions, such as f of g of x equals x for every x in the domain, and g of f of x equals x for every x in the domain of f, then f and g are inverses of each other. We looked at the inverse trig functions in the last section, so last night. So now we're going to look at the composition of the functions. Before we get into the trig, little recall, I want you to evaluate f of g of negative 2 if you're given f of x equals 3x minus 2 and g of x equals x squared plus 5. So a little practice of composition of functions. So pause the video, evaluate that, unpause when you're ready to check. Alright, so hopefully you got 25 as an answer. How do we get that? Well, if I'm trying to evaluate f of g of negative 2, first I want to evaluate what is g of negative 2. So g of negative 2 is negative 2 quantity squared plus 5, which is 9. So then f of g of negative 2 is actually going to be f of 9. What is f of 9? That's going to be 3 times 9 minus 2, which is 27 minus 2, or 25. So f of g of negative 2 is 25. Okay, next, I want you to find the exact value in radians, so this is from the unit circle, of arc sine of negative root 3 over 2, and find the exact simplified rationalized ratio of the sine of negative pi thirds, also from the unit circle. Pause the video, evaluate each of those. Okay, so remember, this is saying at what angle does sine equal negative root 3 over 2, but within the range of the arc sine function. So if I look at my unit circle, that's going to be looking on the right half of the circle, whereas the y value, negative root 3 over 2, that's at 5 pi thirds. 5 pi thirds is not within the range of the arc sine function, but negative pi thirds, which is a coterminal angle of 5 pi thirds, is. So the answer to arc sine of negative root 3 over 2 is negative pi thirds. What is the sine of negative pi thirds? Asking the opposite question, so I find negative pi thirds on the unit circle, which is a coterminal angle of 5 pi thirds. I look at the y value and I get negative root 3 over 2. Okay, so now that I have those, now I want to evaluate the composition. So if I want to evaluate the sine of the arc sine of negative root 3 over 2, we'll think about what I did on the previous problem. Evaluate the inside part first. So what is the arc sine of negative root 3 over 2? That is negative pi thirds. So then this question becomes, what is the sine of negative pi thirds? That is negative root 3 over 2. So here, this is negative root 3 over 2. What if I go in the other direction? What is the arc sine of the sine of negative pi thirds? The sine of negative pi thirds is negative root 3 over 2. So then what is the arc sine of negative root 3 over 2? It's negative pi thirds. This goes back to the definition of functions and their inverses. F of g of x equals x, g of f of x equals x. Okay, so some strategies for evaluating the composition of trig functions, because they're not always going to be inverses of each other. First, evaluate the inside function. So that's what we did here. I evaluated the g of negative 2 first, and in this case I evaluated the arc sine of negative root 3 over 2 first. Here I evaluated the sine of negative pi thirds first. So evaluate the inside function first. How do you evaluate the inside function? Your go-to thing is to use the unit circle. If it's not on the unit circle, try drawing a triangle in the correct quadrant. Be careful about that. If you can't draw a triangle, then use your calculator. That's usually a last resort though, because we like exact answers. So once you evaluate the inside function, assuming it exists, then you're going to evaluate the outside function with the result from the inside function. Again, your go-to is the unit circle. If that doesn't work, try drawing a triangle in the correct quadrant. If that doesn't work, use a calculator. Keep in mind the domain and range of the inverse/arc functions, because those might lead to a possibility of something not existing, or they will be very specific on what quadrant you should be in. Okay, so now, with that in mind, I want you to evaluate these 5 composition of trig functions. So pause the video, evaluate those, unpause when you're ready to check your work. Alright, so for the first one here, the arc cosine of the cosine of 3 pi fourths is 3 pi fourths. How do I know that? Well, I can do the work, evaluate the cosine of 3 pi fourths is negative root 2 over 2, and then what is the arc cosine of negative root 2 over 2? It's 3 pi fourths. Again, if you're confused on that, look at the unit circle at 3 pi fourths. The x value is negative root 2 over 2. This is the range of the arc cosine function, so within that range, where does the x value equal negative root 2 over 2? It's at 3 pi fourths. So that's how I come up with the answer. Here we'll see in the next example, it doesn't always work out that way. We'll talk about that in a second. So the arc sine of the sine of 3 pi fourths. Well, what is the sine of 3 pi fourths? It's root 2 over 2. So within the range of the arc sine function, which is the right half of the circle, where is the y value root 2 over 2? That's at pi fourths. So the answer here is pi fourths. Arctangent of the tangent of negative pi 6. The tangent of negative pi 6 is negative root 3 over 3. The arctangent of negative root 3 over 3 is negative pi 6. And again, this is within the range of the arctan function. So notice, here's the pattern. If these two are inverses of each other, and this value is within the range of the inverse function, that will be the answer. Same thing happens here. These two, in this problem, these two are inverses of each other, but this is not within the range, so there's going to be a different answer. What if the inverse function is on the inside? Well, a similar thing happens. Now, if this number is within the domain of the arc function, because I have to evaluate that first, then this will be the answer. If it's not within the domain, as down here, then I will not have an answer. Now, if that's confusing, you can always verify these. These are clearly not, this one and this one are not on the unit circle, but you could type this into your calculator. So I can do second sine of negative 0.87, and then if I do the sine of that answer, so don't round, otherwise you won't get the same thing back, you get negative 0.87. If I try that here, this is outside the domain, so that is no solution, that does not exist. Okay, well, what if these two functions are not inverses of each other? So now I want you to try to evaluate these 6. So work through them, pause the video, unpause when you're ready to check your work. Alright, moving right along. First one here, arc sine of the cosine of 3 pi fourths. It's negative pi fourths. How do I come up with that? What is the cosine of 3 pi fourths? That's negative root 2 over 2. What is the arc sine of negative root 2 over 2? Negative pi fourths. What is the arc cosine of the tangent of 2 pi thirds? The tangent of 2 pi thirds is negative root 3. What is the arc cosine of negative root 3? Negative root 3 is not between negative 1 and 1. So therefore, it does not exist. The arctan of the cotangent of negative 5 pi 6. What is the cotangent of negative 5 pi 6? It's root 3. What is the arctan of root 3? It is pi thirds. So this is pi thirds. The sine of the arc cosine of negative 1/2. What is the arc cosine of negative 1/2? That is 2 pi thirds. What is the sine of 2 pi thirds? That's root 3 over 2. What is the secant of the arcsine of 1? The arcsine of 1 is pi halves. What is the secant of pi halves? It is undefined. Because remember, at pi halves, I would be doing 1 over 0. That is undefined. What is the cotangent of the arc cosine of negative root 2 over 2? What's the arc cosine of negative root 2 over 2? It is 3 pi fourths. What is the cotangent of 3 pi fourths? It is negative 1. Now, if I went through any of these too quickly, let me know, talk to me in class tomorrow about it. But I'm hoping at this point you are becoming pretty comfortable at looking things up on the unit circle. That's where I'm getting all of these answers from. Okay, real quick before we go into more examples, what is the difference between undefined and no solution? So write down what you think it is, pause the video, write down what you think it is, unpause when you're ready to discuss. Okay, I hope you weren't writing too much, but basically, undefined is a solution. It's just an undefined solution, so that is the answer. As opposed to no solution is saying that we can't solve it, that there is no way to solve it. But undefined is an actual solution. So there's a difference between writing those two. Alright, next examples. What if it's not on the unit circle? What was my next strategy? Draw a triangle. So arc cosine of root 5 over 5 tells me how to draw the triangle. Arc cosine is in the first and second quadrant. If it's positive, it's in the first quadrant. So I draw a triangle in the first quadrant, and I label the sides based on the arc cosine. So it is adjacent over hypotenuse. So then if I do the Pythagorean theorem, this becomes 25 minus 5 is 20. This side is the square root of 20. Or 2 root 5. So now I'm looking at this angle. What is the sine? It is 2 root 5 over 5. Here, cosecant of the arctangent of negative 5/12. Again, this is not on the circle, so let's draw a triangle. Pay attention to the inverse function. Arctan is negative in the fourth quadrant. It's only in the fourth and the first quadrant. It's negative in the fourth. So my triangle is going to look like this now. Here's the angle I'm looking at. Tangent, this is negative 5, and this is 12. And that means this has to be 13. It's very important that I recognize this side's the negative side, that side's positive. Remember, where you put a negative in a fraction does not imply which one is negative. What is the cosecant? Cosecant is hypotenuse over opposite, so we get negative 13 over 5. Alright, I want you to try and do the last two. So pause the video, evaluate those, unpause when you're ready to check your work, or when you get stuck. Okay, so the first one here is 8/5. You can do that without doing any work by recognizing that these are reciprocals of each other. If you drew the triangle though, there still really isn't much work involved because this would be 5 and this would be 8, and I never even need to find the hypotenuse because cotangent is adjacent over opposite. Secant of the arctangent of 1, again because arctangent is positive, it's in the first quadrant. So I draw a triangle, this would be 1 and 1, this would be root 2. Secant is root 2 over 1 or root 2. The only thing you still have to be careful about with these problems is with the inverse function, making sure that you are within the domain. However, if something is not within the domain, it should be relatively obvious if you try to draw a triangle because it will be an impossible triangle. And what do I mean by that? I mean the hypotenuse will not be the longest side. Alright, next. For each triangle below, theta, write theta as a function of x. What does that mean? Well, here, theta, I have the opposite and the adjacent side. So I can say tan of theta is x plus 1 over 10. Therefore, theta equals arctan of x plus 1 over 10. That is theta as a function of x. We're going to stop here, and you're going to go on to part 2.